Hello again, everybody. Welcome to another UCA Smart Grid session. This is part 2 or webinar 2 of the CIM series presented by Mohsen Khadem. Next slide, please, Mohsen. All right, and just some need to knows like last time, the webinar is being recorded. Don't worry about following up to get the recording. It'll come to your email automatically if you're registered for this meeting, as well as it'll be posted just like part 1 on UCA's website and our YouTube channel. Please hold all of your questions if you can until the end during our Q&A section. We'll also have a bit of a survey or discussion section, which if you would please take a screenshot of that one that comes up at the end and then email some answers to us. That will help us a lot in the users group. You're welcome to chat with other participants in the chat box. And then just a little bit of information here about the UCA webinars is we follow antitrust laws, so anti-competitive business practices. The webinar presenters are their own opinions, not of UCA's. UCA-hosted webinars are for educational purposes only, not an alternative to expert consultation. And then if you have any questions or concerns, always contact us at admin@ucaieg.org for more information. All right, Mohsen, I'll let you take over. Thank you.
Thank you so much, Ryan. As Ryan said, my name is Mohsen. Thanks everyone for joining us today. In webinar 1, actually, we talk about CIM, why we should use it and what is CIM. One important thing that we said, CIM is not a software that you can download, install it, and import your legacy model to CIM and say, I am done. That is really a journey. You have to go through many processes. Here, what CIM promises, that is enable interoperability across utility systems, correct? One shared understanding of the grid, many systems, common language. This picture actually, as you see the CIM in the middle, that is the model-centric, that the vision that I have, and should be. The CIM should be in the center of everything. These applications of systems that you have should not start talking to other directly. In the webinar 1, we talk about it, what is going to be a mess if you do that point-to-point, mapping. We put the CIM in the middle as a model-centric, and then all these subsystems, they can talk to each other, correct? That is the way it should be, and we should keep alignment all the time. As you start your project, you go through all this process, you link and so on. You are in that situation, but later is going to be changed. How we typically measure a success in the project, correct? Before we go live, you have the requirements, define business needs and data requirements. Then you design it, you model the solution and interfaces, then you integrate this stuff, correct? You build the interfaces and map data using CIM, and then you test it. You go through all test process, test cases that you have and the business rules, and then go live is coming, correct? The weekend you go live. The success criteria is that interface working and data exchange. You can import, export from your network modeling tool, correct? Data quality and profile compliance, everything is good. You can export data based on the profile, a standard profile, or the custom one that you defined. Everything looks good. Integration, acceptance test, pass everything, and project delivery on time and on the budget. That's great things. The big question that we are asking today, what happens after you go live, correct? That is not, going live is not end. It's just starting another journey with CIM and with your system in general. That is the system, when you go live, more model, system, organization continue to evolve, correct? Nothing is stopping after go live. System upgrades, network changes, new asset DRs added to your grid. You should take care of that. Organizational changes, correct? There are some department responsibilities change, some people they are moving around, or your vendor is bought by other vendor. Process and data changes. All the real challenge begins after go live. After 6 months, 2 years, what's happened? Can our system continue to agree over time? That is the question, and that is hard to keep. This is where many organizations are struggling today. Day one, as we said, and everything, alignment, you got your GIS data, you go through your mapping script, everything converted to your CIM standard and your EMS, SCADA, everything looks good. Everything in sync, same assets, same connectivity, same measurements, same assumptions, definition, rules. Confidence is very high because everything is working. You pass all checkpoints, and the outcome is all systems share a consistent view of the grid, enabling reliable operations, better decisions, and a strong foundation for the future. That is where you want to be, correct? But unfortunately, after you go live, the stuff is trying to drift from what you had the day one. Alignment phase, differences appears, questions grow, and the system diverge. That is something you cannot avoid it. It's happening. You cannot say, I'm not going to touch my SCADA. I'm not going to have outages. You have to plan a new substation, add it to your grid. You have to deal with your outages, a storm, and so on. That your system is moving on dynamically, very dynamically. Different versions comes in, different data, different assumptions, different mappings and interpretations by different team. They interpret the data differently. Then questions begin, correct? Which system is correct? Is it GIS my source of truth? Is my EMS source of truth, or my network model management? Where should I get the right data? Why are values different? What change and when? Nobody can easily answer this question, correct? Then the trust decreases. Reconciliation increases, confidence drops. And that is, in my opinion, the worst things that you lost the trust. Even if you have good data, you cannot trust it, correct? Because your experience say that some bad data, you have seen it, and you cannot trust even the good data. Drift is gradual. It is not one night that you come and tomorrow everything is changed. It is not. Often hard to see until it impacts operations planning or decisions. Correct? It's happening, small things, and if you don't realize, detect them, it's going to be bigger and bigger and bigger. Because these days, the utilities, they have many applications, correct? And they are growing. In our current day with AI stuff, new applications are needed, and you're adding more and more to your system, and that makes it more complex. That is what we said. Day one, everything looks good, but after you're moving on, your GIS model is changing, SCADA is changing, you add new substation, you add SCADA points, you rename them, you change the configuration in the EMS DERMS, and so on, correct? Example of ongoing changes, you will see I have listed on the left side, GIS updates, new data, model cleanup, schema changes, and so on. Then you have SCADA additions, new devices, measurements, configurations, and so on. All these changes coming in, and they are in silo, correct? They are independent innovation in each of them, which is good, but also drives divergency, correct? They are diverging from each other. And what is the result of that? System evolve at different speeds and in different directions. Alignment naturally diverges. That is, the things start, showing up. If you don't catch early in your system, the drift, the changes, then later on you are going to have more impact on your system, and it is harder to catch it. That is another case, hidden assumptions, correct? Many critical assumptions exist outside the model. If you export your model from one system to other system, you are not transferring assumption with that model. Assumption has done somewhere, someday, 6 months ago, but these assumptions, nobody knows about that, or at least is not traveling with the model to the other system. Naming conventions, how assets are named and what the names imply. Aggregation rules, how data is summarized or rolled up, voltage assumptions, ownership boundaries. For example, if you have the utilities that you have transmission and distribution together, then, for distribution department, where is the boundary, who is responsible for what, and so on. This stuff is not going to get with your model, correct? That is the impact. Inconsistent interpretation. Different systems, different teams interpret the same data differently. Mapping breaks, interfaces break when assumptions change. Data quality issues, unexpected results and reconciliation challenges, loss of confidence. As I said before, this is for me very important, that the people, the team, they trust, they lose their trust to the data. Hard to onboarding somebody. If you have a new member resource to your team, and it is not easy to explain from where the data is coming, where it's going, and if he or she has a question, go ask John. You go to John, ask the question, say, yeah, we did that because of that. And say, when? I say, I don't know. Go ask David. Go to David. And the third person that knows the last piece that you need, the puzzle put together, is retired. And you're lost there. You have to go and make your own assumption and so on. That is very important. Assumptions change, context is lost. The model remains, but the meaning shifts. That is very important. The assumptions right now is not coming with your model. What is important here, that make them explicit, keep them documented, revisit them regularly. The assumptions that you did at the beginning of the project, correct? Maybe that was a temporary solution, or you put temporary rules that is valid for 6 months. But after that, nobody went back to double check again, they are valid still today or not. If not, what is the next step, correct? Another cause here, mapping drift. Day one, everything is mapped nicely together. But as you move on, small changes come in. Mapping change over time, new fields added, transformation modified, workarounds introduced, quick fix added to handle exceptions or limitations. You write a small script, a Python script to do something, to make some cleanup, but it is not documented and you don't know, and just one person knows about that script. And later on, this information, they are lost. Temporary fixes and different, interpretations from the data. That is happening. If you don't catch it here, get worse and worse and worse. You don't want to be in that situation. That is the one that make chaos, and you will find yourself in a firefighter situation. Managing the system, maintenance is not easy. You need more and more script to fix the stuff. And you're not aware of impact. What you are changing here is impacting the other system, correct? What this one is happened, business needs changes. System evolve independently. Time pressure and resource constraints, correct? Staff turnover and loss of contacts. Lack of end-to-end governance. And that is the result, inconsistent data, difficult troubleshooting, higher maintenance costs, loss of trust, hidden dependencies. These hidden dependencies that you don't know, that is not documented. That is the hint here, mapping living artifacts. Govern them, document them, review them, consistency, get in your process. If you don't do that, later on, if you are in that situation, that is a project. It is not process anymore. You need put a project here, and it's very costly. And in my opinion, that is the utility after 7, 8, 10 years, they switch to different vendor. I believe that is the reason. After 8 years, 10 years, they see the system is not maintainable, and they think they have to switch to different vendor with different applications and so on. But I believe vendor is not issue here. The issue is all this drift that's happening during all these years, and nobody detect them. That is the reason for that. Organizational drift is happening too, correct? Staff turnover, role and responsibilities changed. I have seen during the projects I was in, different department totally switch and move on to different department, new people, new management, new culture, and they are impacting. They are impacting if everything is not under control and you didn't design from beginning for all these changes, that's going to impact your system. Knowledge silos, correct? You have some resources, they are deep knowledgeable in one area, and you should try to get this knowledge transfer within your team. If this guy get retired or move to different department or leave your company, then you don't know from where you get this information. People and context are as important as technology. That is, I want to mention here. Invest in knowledge transfer, documentation, and governance. Make context visible, keep alignment intentional. As I said, if you don't do that, and if you come to that situation here after 5, 6, 7 years, then this is a project on its own. It's not a process anymore, correct? That is, you should take care of that. Retain knowledge, document, contact, governance continuously. That is the key. Okay. Some example here, for example, a SCADA expansion. You cannot avoid it, correct? You have new points, new equipment, they are coming, adding new substation. And new remote site added here, that is the list what happened. New devices and tags, the screen and logic updates, and data historian update, and so on. At the day one, everything is sync, map, everybody is happy, correct? But the changes are happening. New site integrated, custom points and workarounds, multiple logic versions, they are coming in, highly customized. When you find yourself in that situation, low confidence to your data, to your system, your decisions are at risk. Your planning team, maybe they plan for 5, 10 years, correct? And maybe they come based inconsistent data, they decide they need a new substation, and that is costly. And they plan it, they invest on it, but maybe they didn't need that. And the load that they forecast, that was wrong, and so on. What is the impact? Inconsistent data, different values for the same thing. Broken processes, manual workarounds become the norm. Lower confidence, users question which data to trust. Should I trust the data in GIS? Should I try the data in EMS? My network model management tool, which one is the source of truth, correct? That is hard to say. Partially this is true, partially other one is true, but if you didn't document that, if you didn't reasoning that is hard to say, okay? Then you increase the risk. Decision made on uncertain information, and that is very costly and risky for your operation system. Here, every addition has a life cycle, align the model, the data, and the organization continuously. Expand with discipline, stay aligned, protect trust. That is very important. As I said, if you don't want to be in that situation, that is chaos and firefighter situation, then you should think about it and get this detection, drift detection in your process continuously. Some of them, they need to go back every month, some of them every 6 months, 2 years, depends on their impact, how critical they are, how serious they are. You should be able to categorize them, organize them, put in your process, have the right people, the right team that take care of that and reporting, documenting. That is very important. Otherwise, after 5, 6 years, I guarantee you will find yourself in the firefighter mode. It's not dependent to your application, what you are doing. Is you have bad application? Is not. It's not the vendor issue. Is not. Is the just data drift that you didn't take care of that. You know, if you have a hole in your roof and it's leaking and you don't take care of that, next year you have to spend more money to fix it if you don't fix it today. Some maybe SCADA display is a good drift here to talk about. You know, at the day one, you had all SCADA points mapping to your measurements. Measurements, they are linked to your displays. If something happened, you will see on your display alarming, nicely show you which point has the value over the limit and so on. But after in your SCADA, the point is changed, correct? The new point is 4, 5, 6, and not 1, 2, 3 anymore. For any reason, I'm not saying it's a good idea to change the name of your points after you go live, but it is happening. I have seen it. And even before going live, is happening that the naming convention, they use different protocol. They try to use 61850 for substation standardization, and then they decide to rename it and make a naming convention that makes sense for operator. And then at that time, it's broken. Your displays, you come, operator say, hey, my display is not working. It's showing, open, should be closed, and so on. And that is the stuff we should take care of that. Display show bad quality or say value. Alarms may reference the wrong point. And that's very important, when operator lost the trust to what is operating, that's very dangerous, in my opinion, because after that, he or she cannot trust any data, even if they are good data. And that's bring the stress for everyone. Yeah, display doesn't match SCADA database, operator trust, and situational awareness suffer. The SCADA database changed, the display did not, the integration still works, the operator trust does not. This is model drift. I guess you have seen eventually, if you were in the project, big projects, that they are doing all this mapping, linking SCADA to EMS and alarming system and so on. You have seen issues like that. Network reconfiguration, correct? What is changed? You get a new feeder added. A new feeder is built to serve load growth in the north zone, for example. Switching a schema updated, recloser or recloser, and the device moves. Devices are relocated or replaced to support the new configuration. All this stuff is happening. You cannot avoid it, correct? That is part of your business. Day to day, that is the stuff you have to deal with that. But before cutover, you check it. That was a kind of a snapshot of your model, current model, get to the new model. But after that, the stuff start moving and changing. As I said, I don't, or I don't want, and you don't want to be in that situation. Even it's not good for vendor either. If I am talking from vendor side, that is really a stress for the whole team. Every time you don't want to wake up at 2 a.m., the customer call you and say something is not working. You want to, make sure you don't come to that situation, because everybody is in trouble at that time. Yeah, what we lost, accurate topology awareness, reliable protection coordination, trust in analysis results, that is the planning department. You cannot trust the results that they are delivering, Operational confidence, we lost that. Institutional knowledge, some people with the knowledge, if they leave the country or even change the organization, I have seen in the project, the knowledgeable guy move from this department to different department. It still was in the same company and we could reach him, but that was not easy as before. Before he was a team member, correct? I could take the phone and call him, chat with him anytime, but now was difficult. I should go through his manager, get his time, and so on, that you can talk to him. Safety and compliance, and that is the impact, operational risk, incorrect switch or protection actions, data model errors, bad data in, bad inside out. Say junk in, junk out, correct? Inefficiency, higher costs, loss of trust. That is, as I said, in my opinion, very important. We want to have a system that everybody trusts, and when they see the data, they can make decision based on results, okay? What is here the key takeaway? Network reconfiguration is continuous, alignment is not. You cannot avoid network changes. I had in the project that 200 to 300 changes per day. Can you imagine? And if they are not aligned, if you don't have the right architecture there, for sure you are going to land here a couple of years later. Even if you fighting here to keep up and running, work around, working very hard to keep the system up and running, but after a couple of years, 5, 6 years, you will land here. It's not, you put too many bandage on the system that you don't see the system anymore, and that at that time you make decision to switch the vendor. But I believe vendor is not issue here. That is this drift that we see that. Okay, as I said, the grid will keep changing. We cannot avoid it. We cannot say we are not going to have outage. You cannot say we are not going to add any new equipment substation in our grid. You will, and you do it every day. But alignment must be part of our ongoing operations. That is important. See the changes, update the model, verify the mappings, protect the outcome. That is the stuff that, we keep in loop. The alignment is very important. The other example here is DER growth, correct? The same things. DER is added, rooftop solar batteries, EV chargers are added every day to your system. The plannings, they are based on this data, they are doing the planning, future, expansion on the grid and so on. If you don't take care of the drift at the same day that we see that, maybe they are very easy, simple, but we should take care of that and bring to the loop that we don't land to that color, that they get chaos there. DR will continue to grow. Alignment must be designed into our process. Grow the system, grow the alignment, protect reliability and value. And that is the things. And the key takeaway, DR growth is accelerating. Alignment must be continued. Update the models, validate mappings, monitor data quality, keep decisions reliable. Yeah, that is the other example, plannings and operations, correct? What drives the gap, the different time horizons. The planning is for 5, 20 years in advance, in future. Operational, manage minutes to months. And different objectives. Planning optimizes the future need. Operations optimize for reliability today. Reliability today. That is, operator in the operational dealing with the current, what's happening in the field, a transformer blowout, that this switch open. They are dealing with that one, but the Planning is 5 years, 10 years. Do they need new substation? Do they need to replace a transformer and so on? They make a lot of studies there. And the same things, they impact poor decisions. Plans don't reflect reality. Operations make risky calls. Normally, what I have seen, the operational and the planning department, they are in silo. They don't talk to each other. They don't work on the same model. They get a snapshot of the model, start planning on the top of that. They do all the studies, but the studies that they are doing, you don't know. You can trust the result, what comes back, because in between, the stuff is changed. They need another use case for current situation and so on. Planning and operations need different views, but they must stay aligned. That is the key. Alignment is the key here. As I said before, make alignment a process, not a project. If you come to after 5, 6 years, you come to the last column that we saw so far, yeah, you don't have any other choice to go to a different vendor. But I tell you, this is not going to solve your problem, maybe for a couple of years, but you will land in the same situation that you were before. Bridging the gap protects reliability, reduces costs, and builds trust. Align early, align often, align both ways. That is the key. Vendor replacement, the same stuff that we talked, before is vendor A, legacy system, data model, proprietary structure and naming, interfaces, custom integration and file formats, they are different and so on. You have to try mapping and get to the new format with a new vendor. But the good things, if your CIM, as you saw the first picture, the CIM modeling was in the middle, the centric one. If you have this one in the place, your pain is less. But if you don't have CIM already and you try to go from vendor A to vendor B, that is very difficult. I don't recommend that. If you are deciding to change your vendor, please make sure your CIM is in place. Your model is centric, and all subsystems, they can talk to your data through CIM standard. And that is source of truth, should be, Otherwise, moving from A to B is not easy. Data issues, incorrect or missing data after migration, broken processes, workflows fail or require manual workarounds, poor decisions, reports and analytics no longer reliable. Delays and rework, projects take longer and cost more. Loss of trust. Again, I come back to trust, very important, because I have felt that in the project, should I trust this data? That's very big impact. Even 99% of your data on the display that you see, they are correct. Maybe once or maybe 100% they are correct. But because you don't have trust to the system and data, you cannot make a good decision. At least you delay your work that you are doing. Replacing a vendor is more than a technical change. Rebuild alignment, validate everything, communicate early. Another example here, cut over drift during system replacement. Okay, when you come to the cutover, day one, everything, you get a snapshot from your GIS. Let's say your GIS is source of truth. You get to your new EMS system from vendor A, and they are trying to get all mapping, get the data up and running, be able to run the topology processor, power flow, and so on. But the GIS is not stopping, correct? The utility has to serve the customer. You cannot stop say, hey, we are moving from vendor A to B for 2 years. We are going to fix it and come back. It's not true. They have to deliver electricity every second. And that's is moving on. GIS is evolving, project team is building and testing the new system based on the snapshot. And then GIS keeps changing. New substations, new feeders, new DRs, and so on. But still your new EMS is working, testing on the snapshot that they did day one, correct? Then you come to the cutover weekend. It is large delta to reconcile. You see thousands of changes missing, new assets not in new system, deleted assets still exist, connectivity differences, ID and attribute changes, switching differences, you name it. I'm sure for you people are here and you were in this project, you can mention 10, 20 others and more. And each utility actually is experiencing different issues. I don't want to say it is 100% one-on-one, all these issues that I am mentioning here, everybody is going to face. No, but maybe the same, taste, the same theme is there that you will see this or either one in different version of it. That's going to be happen. Validation and quality checks, testing and impact analysis, manual cleanup and fixes, cut over delays and risk. Never I was in a project that we could cut over, on time, all the time was, push out from customer side, from vendor side, no matter. That was something happened. Oh, we forgot to this requirement. Beat that, we cannot go live, Happened just 1 week before going live. And we had to delay the ongoing live, because customer said, without that, we cannot go and it's not approved. That's it, you have to do it. Challenges, the utility keeps operating and the model keeps changing, correct? As I said, they are not stopping. They add new equipment to your grid, but the new system cannot be kept in sync until cut over. That is, the process is not there that everything is in sync and live you get update. At what time, before you go live, you stop it, you get a snapshot, you try to make all your testing, you go through all your test cases to pass topology process or, powerful and so on. And the day cut over, you need to get new stuff inside the system that you have a complete system. Otherwise, you are partially operating the system. What we need, continuous change capture, correct? Versioning and delta management, automated comparison and validation, reconciliation tools and processes. As I said, here that is the stuff you will, face after you cut over. And the goal here is keep models aligned throughout the project and reduce cutover risk and cost. The utility kept operating, the project kept building, the models stopped evolving together. This is cutover drift. What the industry is focusing today, they are spending money on new tools, investing in the latest technology, future and functionality, adding capabilities and advanced functions. Especially these days, the model and grid modernization is moving very fast, especially with AI initiatives and innovations. And you should keep up, the integrations, connecting more systems and platforms, make it more complex. Security and compliance, project and implementations, they are all necessary. They are important investments, but not enough. Tools and projects don't guarantee alignment. Alignment does. That is the key. The one word here is alignment. I am repeating in most all my slides here. That you should keep the alignment as a process if you don't want to handle that or take care of that as a project. What we often overlooked, as Omid stays aligned, focus on tools, not alignment, siloed ownership, validate infrequently, and ignore small gaps. The biggest misalignments start small and grow over time. Awareness today prevents risk tomorrow. As I said, that is the key. If the drift happening the day after go live, try to document it, capture it, talk to the team, and try to fix it early. Day one, vice versa, 5 years, 7 years ago, that is the situation that I was talking to you. If you find yourself in that situation, which if you don't take care of alignment, you will. And that's the reason the vendor, the power utilities change the vendors every 7, 8, 10 years. What a smart line can drift apart. Alignment must be maintained continuously. That is not something that you set and forget. That is something you keep in your process. Try to keep it the assumptions. Okay. For example, assumptions, you have a three winding transformer. The planning that he's using, take this model, might be the tools that he is using doesn't support the three winding transformer. What he's planning, he's modeling two winding transformers, correct? All assumption is changed. And the next engineer take the same model to different tools which supporting three winding transformer. And he's assuming all this equipment, it should, represent what is the field, the equipment in the field, correct? Then these assumptions, two engineers, they did the modeling study, but they didn't, or there is no mechanism there to feed back the assumptions to the model, correct? If that was the case, the second engineer, if they received the model, say, aha, this model was modeled in other tools for that planning, for that study by that guy as two winding transformer. That is, this knowledge, these assumptions is not moving with the model across. That's why I'm talking about it. We should keep all these assumptions that everybody knows, documented, and you know what kind of data you are dealing with, who owns consistency? Everyone. That is very important. That you should not drop the ball. If you are as a leadership, the set expectations and priorities, the data owners define and maintain trust data. System owners, ensure systems follow agri standards. If the drift, they see that, they should raise the flag, business users, use data correctly and provide feedback. Governance team, monitor, validate, and drive alignment. Project teams, build with standards and communicate changes. That's very important. And who owns consistency? Everyone. Everyone in your project should keep it, should report it, should understand. First, maybe that is the education is coming first. I didn't mention here in my slides, but maybe it's education. That you educate your team. That is the situation. If you don't care, in 5 years, we will go to that situation, that Mohsen was talking about. Let's understand the situation, what it is, and how we can, detect these drifts on time. Don't let to be 5 years later, we are in the chaos. How do we detect the drifts? That is the monitoring, correct? Track key data, models, and integrations. Compare, check actual results against expectations. Actually, these days with AI innovations, actually you can automate that column, maybe the comparison that automatically run for you every day, every night, at 2 a.m. This is running and make sure that the results is good. You don't have any drift in some area. You can make AI agent for different drift detection, and that's great actually use case. You can improve your system that you come to that chaos situation. You can capture the drift very quickly. Spot changes, gaps, or inconsistency. That is the stuff you can even automate, and some supervisor can, go through the report and make sure they are documented, they are not false positive, alarms. and then alert, notify the right people at the right time, and action, investigate, correct, and prevent. Drift is normal. Detecting it early is the advantage. Measure, compare, detect, act, and repeat in a loop. That is the key. If you don't want to land after 5, 6 years in chaos and in firefighter mode, that is something you should educate your team. You should work on different area in your system. Depends what you have. Is it SCADA, EMS, DERMS, or whatever it is? Try to find the spots that could, go out of the rail, and you need to bring it back to the track. That is the next industry challenges, correct? That is, everything is disconnected. If you don't have CIM in the middle as a model-centric, you have bigger issues. But interoperability by design, what I am talking about here, interoperability from my point of view is not easy. Just you exchange the model and say, good, vendor A, export the model to vendor B, we are good. Interoperability test is done. That is more to it, This is just only you make a snapshot from your model and you export it as XML, RDF, CIM standard format, and you pass to other vendor, other application. That is data exchange. That is, you understand the language, but when I talk here about a story, the content of that story to understand, this is something that is, we should take care of that. Interoperability by design, that you understand the meaning of the data, the context of the data. The data, the same data, in different contexts, maybe get interpreted differently and is correct to interpret differently. And the results come back based on that context. But the key is that this context and the result and the decision all together as a package, that this model was, this study ran based on that context and that meaning of the model, and then makes sense. And if you pass it to different engineer, check it and say, oh, that was this study done, I know, then this makes sense. I do just change parameters to make it better, or refining this study and so on. That is the key I'm talking here, interoperability by design. From integration to interoperability, from projects to sustainability, building an industry that works as one, not in the silo. What CIM solves and what it doesn't. That is important. Maybe you print this one and put on your desk. What CIM solves, the common semantics, provides a shared language and consistent meaning across systems, correct? That is interoperability today, that they know the same format and the same, if you say breaker, this breaker, which attributes should have, which association has with other objects. That is your expectation. If you receive the data, you're expecting to receive. If it's not, then you raise the flag. A standard model exchange, enables structure, machine readable exchange of grid information. Vendor interoperability. That is the reason the vendor, they can, EMS from vendor A can talk to EMS or SCADA from vendor B. That is reduce, lock in, and enable system from different vendors to work together, okay? I am checking the time. Maybe I have to go faster. And that is what CIM alone doesn't solve governance. CIM does not define who owns the model, change, and so on. Change management, CIM does not manage EMS, GIS, SCADA for you. Version synchronization, CIM does not keep system and models in sync over time. Ongoing model validation, CIM does not detect drift, correct? Data trust, CIM does not guarantee accuracy, completeness, or fitness for purpose. Closing thoughts is coming here. That is, interoperability is not done it is an ongoing responsibility, okay? Share commitment is essential. Everyone has a role to play. Monitor, revalidate, and adapt. Stay ahead of change. Design for consistency, deliver with trust. Let's build an interoperable future together. Connected, consistent, trusted. Here we come to the question and discussion. Actually, I put this one after question that Ryan was talking about, if you can make a snapshot, because very important, guys. Your experience helped to entire industry improve. No matter you're on vendor side, your utility side, your consulting company, you have a lot of experience. You have seen it in different projects. I categorize in three, category here. How does your organization manage model drift? Have you ever thought about it? Let's go through that. Make your team and give them this question and try to get it back. Who owns model consistency? Ask this question inside your team, your company. Ask the executive managers or whoever is responsible. As I said, everybody is responsible for the consistency. And what lessons have you learned after go live? What worked well? What were the biggest surprises or challenges? What would you do differently next time? If you do that, we know this answer. Maybe the other utility that they didn't start to go through that journey, they can use this stuff and save tons of money, tons of time, tons of stress. I please, I am asking you, that is really helping everyone. Just try to share. If you can go through this, even it's good. Even if you don't share with us, just go through your team inside your company and try to get the answer to this question. And you will be surprised and how it goes, the answer with this question, and collect them, document them. And if you are okay, share with Ryan or myself. And actually, if we get good feedback, I like to get the webinar 3 based on these feedbacks, and we come together and kind of brainstorming and say, hey, if 10 utilities, they are seeing the same issues, the same pain, why they are going to solve it 10 times? Let's come together and make one solution, good solution, and repeatable solution that everybody can use, and is much cheaper, and is faster, and it's better for everyone, for utility, for vendors, for everybody, for users. As you know, the North America GMS is coming, the standard that you are planning for North America. What? The European, they have this CGMES, they mandate actually using the SIM and exchange between the countries, the model. And in USA, there is no mandatory yet, but I believe should come in a couple of years. Maybe they cannot avoid it. Let's think about it, and maybe we can influence the standard that is coming and say, hey, if this stuff gets through a standard that everybody can use it and reduce the cost for everyone, please get involved. That is my message to you. If today you can talk to somebody in your team, in your company, no matter where you are in the vendor side, utility side, consulting side, and talk to the people and say what you think. Can we answer this question? Make an Excel sheet and find out. And that's good for yourself too, that you know where you are with your system. Are you in the early stage to find a drift, or you're already in the chaos situation? What you can do, what is the solution for that? Next time, I like to, if we get enough feedback, then I will collect them and try to summarize them, and again, put different group and say, okay, 10 utility got this issue, 5 utility got this issue, 2 this one, and how we can solve it, and which one we can put in the standard. Right now, everybody is working on a standard. They are trying to get the feedback, brainstorming what we get as North America, power utility, power industry, what we are going to do, what we are going to advance CGMES. They have done a great job. And what we can do, make additional that the next day can adopt what we have done it here. That is the teamwork, and I guess this is going to help everyone, and I appreciate. I don't know, I don't have any slides after that. I let you hear that you can make a snapshot or think about it, or you can ask Ryan later on too. Thank you guys, and I don't know, Ryan, if there is any question I can answer. If not, please add more than question. Important is that's life for me, and I am open. Even if you don't get answer to your question, please give me a call or send me a text. I can be one-on-one or whatever you make in your team, and come even internally talk about you what you need for this alignment, and we can talk there and make early detection that you don't land that chaos. Thank you so much. Ryan, back to you.
All right. Thank you, Mohsen. We greatly appreciate your time and effort with these. It's so helpful to have this extra bit of education for the community. We do have one question, but I also want to emphasize back to this discussion topics page here. Feel free to email that is to either Mohsen or I. And my email is ryan@ucaig.org. Or you can simply put it in this chat. I think the chat will still be available after the meeting ends. It does look like we might go over a couple minutes. I hope that that's okay. If you have questions, put them in the Q&A now or the chat box there on the top. You'll see on your panel chat or Q&A. You can put them there. And if we don't have time to answer your questions, I'll stay on with Mohsen for the recording, and we will record it after you leave and have your answer for you. So just check that out after the recording, after the meeting ends. Okay, Mohsen, while they're putting in some Q&A questions, there is one from Matcha. They're asking for you to clarify, what does this mean in concrete terms? Is the best practice to build a CIM-compliant data layer, integrate the relevant data there, and use this data layer as a single source of truth?
I believe that is the case. As I said, model-centric, correct? You keep the model-centric, and that should be your source of truth. And around that, you make the adapters, and you make whatever the data they need. Right now, in CIM standard, we have the profiles, correct? The CIM is huge, like an ocean, but you need, one glass of water. You are not going to take the whole ocean. What you do in CIM standard, you define a profile, correct? CIM comes with some standard profile, for example, DL for display layout, or 452 for equipment, for topology. They took the subset of the whole canonical model, CIM model, and deliver. But with that layer, even that, I have seen, for example, CIM for the planning, they get the model. They didn't know what kind of model they get, say, okay, we deliver, 452 profile that is for equipment and everything, topology, connection, they are there. But even that maybe is not exactly what they need. But if you have your CIM as a model-centric and you define kind of the functional block, that is my vision, in a setup, even the profile is a subset of your full model. Even that is too much sometimes for some downstream application that they are doing some simple stuff, correct? In the planning, maybe they don't need everything, they need just one substation from that substation, this equipment and this equipment, only these attributes. And still you can define your profiles, the custom profile. You can copy the 452 that you have, and then you resize it. Yes, I believe that there is a CIM compliant data layer. Makes sense to me.
Thanks, Mohsen. We do have one Q&A over here on top of that question from Diana. In your opinion, how would the risks discussed here be impacted by implementing time-based modeling with CIM? Follow-up, it seems like there might be an increased amount of alignment as systems and divisions are onboarded, but through strong governance, it would reduce long-term drift. If you need me to reread the question, Mohsen, I'm happy to do that.
Is it, yeah, they're saying the time-based model, yes, that is what's happening, correct? The planning and operational. They are not, as I said, the planning is planning the model for 10, 20 years from now. But they should work on the same model. That is they are in silo right now. But if your NMMS tools that you are using today is supporting time-based modeling, which they show some, they are on the job-based modeling or time-based modeling. With time-based modeling, I believe that is a solution you have to go. You take the model from the operation or for planning, they start working on it. They go to bus branch model, and on the operation also is the node breaker model. But they are working on the same. As the time goes closer, closer, and closer, the same modeling, the planning model go back to the operational, 6 months from now. That was 5 years they planned out. And 6 months from now, they review the model again and go to the operational. And they can start adding more equipment to that and go through our validation. This is not the drift, this is the time-based. If I understood your question, the time-based actually is helping that you solve that gap. They can plan it, but at least they know the base is coming is real. And if something happened in the reality, they can get the planning team, they can get the model again and make a use case and the study on the what is happening today in the field, correct? But if they are in silo and they are job-based modeling, then it's not that easy to take it. But with the time-based, you can make your MCR model change request for a piece of the changes that you are doing or the team is doing. And then you can even have the pick and choose, correct? You can say, okay, these changes, these jobs, I can take to the planning model, push to my base model, what I have on the planning side, and make my study. And later you can come back and say, okay, these changes should go to operational, for example. Then that is pick and choose. It is not the whole model. This one is going actually to reduce the drift from your base model. If I understood your question correctly, sorry. If not, please email me or we can discuss it more. But time-based modeling, I guess that is the way you have to go. And because the model changes is not happening one day, okay? One issue that I have seen, as I said, they have 150, 200 changes per day, but maybe they can go in a couple of hours or days in delay, but if the system is not supporting that, they collect everything and put in one big job and push to the model. And this one makes actually the more difficult, the validation, the conflict that you have. The modeler A did something, the modeler B did differently, and the time that comes to merge all to the base model, then you have conflict. Then you should have a very good conflict management in place that capture all these conflicts. Otherwise, you are pushing bad model to your downstream systems. I know over time I have another meeting I have to go, but I really appreciate if you can put your thought on this slide that you can see right now. Is very important. Please help us that we can help you. And go through your department, to your team today, put this on the table and say, hey, what do you think about these questions? What do you think where we are? Just give you a score, and find out where you are in your system. If you don't want to replace your system in 5, 6 years, go to different vendor. Please do this study for yourself internally. And if you're okay, share with us. We keep the confidentiality, we don't tell which vendor, which company provided. Just I want to know the pain and the issues that you have. Please share that one with us that is valuable, and you can save a lot of money for your friends in different company, in different utility. I appreciate that. Thank you, guys.
Thank you, Mohsen, and we appreciate you and your time. You have a good day now, sir. And thank you, everybody, for attending today's session. Please watch for part 3. We'll probably post that onto our webinar, or sorry, our LinkedIn page, and probably within a couple of weeks. Thank you. Have a good day, everyone.